Hello everyone. So today we will go to start the lecture about math, and the specific topic is math differential equations. The basic process is here. I will read the official text about a book, and then during this process, I will give my personal understanding of this content. And maybe I will open Microsoft Whiteboard to write some notes about this content. So let's get started. And this is the chapter 1 introduction. In this first chapter, we provide a foundation for your study of differential equations in several different ways. First, we use two problems to illustrate some of the basic ideas that we will return to and elaborate upon frequently throughout the remainder of the book. Later, to provide organizational structure for the book, we indicate several ways of classifying differential equations. The study of differential equations has attracted the attention of many of the world's greatest mathematicians during the past 3 centuries. On the other hand, it is important to recognize that differential equations remains a dynamic field of inquiry today, with many interesting open questions. We outline some of the major trends in the historical development of the subject and mention a few of the outstanding mathematicians who have contributed to it. Additional biographical information about some of these contributors will be highlighted at appropriate times in later chapters. For chapter 1.1, some basic mathematical models, direction fields. Before embarking on a serious study of differential equations, for example, by reading this book or major portions of it, you should have some idea of the possible benefits to be gained by doing so. For some students, the intrinsic interest of the subject itself is enough motivation, but for most, it is the likelihood of important applications to other fields that makes the undertaking worthwhile. Many of the principles or laws underlying the behavior of the natural world are statements or relations involving rates at which things happen. When expressed in mathematical terms, the relations are equations and the rates are derivatives. Equations containing derivatives are differential equations. So maybe here the very important keyword is that differential equations. What are the differential equations? They are the equations obtaining derivatives. You can see here, equations containing derivatives are differential equations. With derivatives, derivatives. Therefore, to understand and to investigate problems involving the motion of fluids, the flow of current in electric circuits, the dissipation of heat in solid objects, the propagation and detection of seismic waves, or the increase or decrease of populations, among many others, it is necessary to know something about differential equations. A differential equation that describes some physical process is often called a mathematical model of the process, and many such models are discussed throughout this book. In this section, we begin with two models leading to equations that are easy to solve. It is noteworthy that even the simplest differential equations provide useful models for important physical processes.